Welcome to Chem Plus. Welcome to Chem Plus. Today we've decided to look at a topic that is very important for your exams. The topic is covalent bonding. This type of bonding takes place in non-metals only. We've already looked at ionic bonding, which is a metal and a non-metal. Today we have switched to look at covalent bonding, sharing of electrons. Now let's have a look at these atoms here. We've got an atom of hydrogen and an atom of hydrogen. Now if you look at the periodic table, hydrogen is atomic number. You look at the periodic table. What is the atomic number for hydrogen? The atomic number for hydrogen is 1. So let's just take that down. Hydrogen is atomic number 1. So what does that mean? It's got 1 electron in the outer shell. So that hydrogen has got 1 electron in the outer shell, and this hydrogen is also having 1 electron in the outer shell. So what are the two hydrogen atoms trying to do to achieve a stable arrangement of electrons in the outer shell, the stable octet arrangement of electrons? They're going to share. They are not going to gain 7 to have 8. This one has got 1 electron in the outer shell. This one, they can only have 2. And how are they going to achieve that? They're going to achieve that by sharing of electrons. This hydrogen here needs 1. This needs 1. What you need is what you share. So this one shares its 1. This one shares its 1. And there you go. There you go. So now the two hydrogens are happy. They're sharing electrons. This is what covalent bonding is all about. Now then, if we have hydrogen and chlorine, you got to use your periodic table to find out the atomic number for chlorine. Atomic number for chlorine is 17. Atomic number for hydrogen is 1. Now this is where the problem is. You are not going to put all the 17 electrons for chlorine in the outer shell. What are you going to do? You got to come up with what is called the electron configuration for chlorine. How many electrons are in the first shell? How many electrons are in the second shell? So the electron configuration for chlorine is 2, 8, 7. 7. That's why chlorine is in group 7. Now, chlorine needs 1, hydrogen needs 1. Let's see how this is going to work out. Remember, we are only showing you the electrons in the outer shells only. So that's your chlorine there, that's your hydrogen there. Hydrogen says, I need 1. I need 1, so I'll put 1. Chlorine says, I need, those are the 7 electrons. Chlorine also needs 1, so it will put its 1 electrons in the sharing pool, and the other ones remain the same. There you go. That's hydrogen chloride. What you need is what you share. Now then, let's look at carbon and hydrogen. Again, you need to use the periodic table. Carbon is number 6, atomic number 6, so it's 2 and 4. So that means carbon has got 4 electrons in the outer shell. We are not talking about the 2 shells. We are not drawing the first 2 and then we are not drawing that. We're just drawing the outer shell electrons only. Then your hydrogen is atomic number 1. So it's still having 1 electron in the outer shell. How can carbon have 8? And how can hydrogen have 2 in this situation? Let's have a look. What we might need to do is one carbon has got 4 electrons in the outer shell, right? It needs 4, so it's going to team up with 4 hydrogens. That's the only way this is going to work now. and each hydrogen needs 1 electron, so it donates its own in the sharing pool, its own in the sharing pool, its own in the sharing pool. By so doing, carbon now has got 8 and hydrogen has got 2 electrons in its outer shell. Now then, let's look at our last example in covalent bonding. What is covalent bonding? Is the sharing of electrons between 2 nonmetals. So now we've got oxygen and hydrogen. I want you to pause the video and try this. If you want, you can pause the video and try this. Now, hydrogen again is still atomic number 1. Oxygen is atomic number 8. You are not going to write all the 8 electrons for oxygen in the outer shell. Remember, there are 2 inside shell and 6 outside. So ideally oxygen is having 6 in the outer shell and hydrogen is having 1. So what's going to happen now? Oxygen needs 2, so it needs to share 2 of its electrons, and hydrogen needs only 1. It needs to share 1 of its electrons. Now then, let's have a look. There you go. We've got our oxygen and 2 hydrogens. Oxygen needs 2, so it's going to share 1 there, 1 there. Hydrogen needs 1, it's going to share 1, and it's going to share 1. So how many did we have for oxygen in the first place? We had 6. So 2 are already being shared, so 2 will remain there. Right, I hope this helps. It's now time for you to